Welcome to ISL Enabled Virtual Lab of CSIR.
And now it's time to ask a scientist.
Continuing our discussion about why we like chocolates, we now have Dr. Nandini Chatterjee Singh, who is a physicist turned brain scientist from National Brain Research Center in India.
Dr. Chatterjee, we just learned that when we eat chocolates, we are experiencing the taste of the chocolate, and there are memories that we have with chocolate. So it makes us happy. So, similarly, I want to ask you, how do these multiple components of something contribute to making one experience?
So that's a big question. I think we are still trying to figure out what all goes into formulating an experience. But I will try and dissect to the best of my ability what might be the components of such an experience. And if you go back and see what are the components that go on to make chocolate, there's caffeine, which is probably the stimulant in chocolate. And that caffeine is what is really acting on the attention aspect. A very important part of any experience to become memorable is to actually participate in it. We do a lot of things unconsciously. We just eat a bar of chocolate without paying too much attention to it. And at that point in time, the experience is not so flavorful. But if you sit down in a corner or, wherever you are and just focus on the chocolate, that experience becomes so much more flavorful. So I think that's a very important part of building the experience around chocolate. Chocolate, and apparently even dark chocolate particularly, contains something called phenethylamine. And this is the precursor to dopamine, which is the feel-good hormone in the brain. So we already have, again, three things now. So there's dopamine, there's attention, and there's reward. And there's stimulation that's coming in from caffeine. These are pretty much the set of ingredients that can really make any experience good. And when they're all present in chocolate, it's bound to make it very relevant and important and rewarding for us. So a balance of all of these in the right proportion is what gives chocolate its flavor and adds to that experience. If you eat too much chocolate, you don't enjoy it so much, I think. The timing and the proportion also make a huge difference. So I think it's primarily a combination of these four. And of course, I'm sure there's some sugar in there, the glucose, which adds to the enjoyment.
Yes. But then, as you said, that these scientists have studied these chemical molecules in the brain, it makes us wonder, how do you study these things in the lab? Because definitely we cannot open up the brain and check these molecules. So there must be certain machines that help you understand these things.
So in humans, you could study it in multiple ways. One is to just do well-designed, well-controlled behavioral experiments, okay, where you get people to eat a bar of chocolate, but you sort of randomly assign them. So you don't know who's eating chocolate and who's not. My own work is primarily focused on functional imaging. So essentially what you're doing in functional imaging is there are certain regions of the brain that are participating in a particular activity. So in order to identify which parts of the brain are participating in that activity, what happens is the energy required by those areas is sort of higher. They need to do more work. So they absorb some more of the oxygen to be able to create a difference in the dipole moment. And that is detected by the scanner because it's a magnetic resonance imaging scanner. That's the activity that happens. And then this is then subjected to analysis. So you're using a principle of physics there, which you can then amplify to try and understand the biology behind it.
And is this mission like the ones that we see on the TV where people show how brain is studied, where they have this gigantic machine?
MRI is what it's called.
Yeah. And what's interesting is that this is completely non-invasive and not at all harmful at all. When I started this work with children, when we were trying to see how children learn to read, how children were so much more willing to get into the scanner. They were so excited about it because I told them we are going to take photographs of your brain. And after they did the task, many kids came back and told me, anytime you want to study how to play games, please call me and I will play games in the scanner for you.
Or maybe eat a chocolate.
Yeah.
So you mentioned that there is a lot of physics that's behind MRI machines. Why does the intersection between physics and brain science interest you? How did you get into this?
I studied physics for a living for a long time when I did my PhD. The physics I studied then was primarily a lot of theoretical physics, not so much experimental physics. And in those days, I was looking at complex systems and looking at a lot of mathematical and, computational modeling. And then during my postdoc, people were applying methods of physics into biology. Mathematical biology is something that was coming up a lot. And so I thought that I would, sort of try my hand at trying to understand some of this. And I got into a lab that was again applying mathematical models to study properties of neurons. Okay. So essentially what I was given was signals, which were signals recorded from the brain. And that's what I started doing. But during that time, I also started to see, this was a lab at UC Berkeley, which was looking at zebra finches, And zebra finches are birds which learn to sing, but they follow a model of learning which is very similar to humans. It's used as a model to study human learning. I got fascinated by this whole model for trying to use zebra finches. And lo and behold, I got attracted towards, the experimental part of the sciences. But here's what's surprising, and it surprised even me. I came back to a position in India again to study computational neuroscience after this postdoc. But then NBRC got an MRI scanner, and I was a physicist who understood how the MRI worked. And so I was tasked with, you have this machine here, you understand how it works, so you should start beginning to use it. And I was, in those days, studying speech, not so much language. And so because I understood the physics of the scanner, I got into starting to study it. My students and I have pretty much learned how to use the MRI scanner, functional imaging together. It was fun being a student again. And I think I just want to be a student all my life.
Super interesting. The fact that you can learn at any stage in your life and be interested in something new and taking up that challenge, I think in itself is quite inspiring.
And I think one led to another for you. You started off as a postdoc studying the physics part, and then you sort of made that graduate transition.
You have to just be unafraid and be willing to learn. And my only advice is just don't stop learning. So I think curiosity is critical to being passionate in anything you do, in anything you enjoy. And that's why curiosity is important. The world is such a wonderful place that if you're not curious, you're actually going to miss out on understanding a lot of the world, If you just follow what everybody's telling you, you're looking at it from their eyes, not from your own eyes. And that's something that you're missing out on very much. So curiosity, reflection, introspection, I think are critical to science.
Thank you so much. That's been so lovely, Nandini.
So, Utsuka, what did we learn today?
Eating chocolate is an experience. The components, that is, mix of sugars, fats, milk, cocoa, and caffeine, together make our energy-craving brains very, very happy.
And Dr. Nandini Chatterjee explained to us how they study these happy experiences using the principles of physics.
But listeners, what we know about the brain's wiring might change as we get more evidence over time.
Who knows? In the future, it might be you who might study human brains and find out something about them that we never knew before. So, that's it for today.
If you want to know more about today's scientist, check out their profile. The link is in the show notes.
If you have any questions you want us to explore, shoot them away to indiaaskswhy@gmail.com.
If you would like to talk to us directly, then join the fun on our Telegram group. Again, the link is in the show notes.
For updates on India Asks Why, follow us at India Asks Why on Twitter and at India_Asks Why on Instagram.
Shweta N. Hegde and Ruchi Manglunia are the hosts for the podcast.
Indulekha MS edited this episode.
And Khushi Goyal transcribed it.
And we are funded by India Biosciences' second outreach grant.
Until next time, till then, stay tuned and stay curious.